Okay. Hi, everyone. Let's start with the techniques of integration. First thing, we will start with the integration of substitution. Integration by substitution. So many times integrand is reduced to the standard form by making a suitable substitution. And in those cases, we go for the integration by substitution. Let me show you how we will go ahead with few examples. Suppose the question comes, evaluate integration x square plus 1 under root and 2x. Right? So suppose we say let u equals to x square plus 1. We are substituting this value equivalent to u. Therefore, we can say du upon dx will be 2x. Yes. So we can say du equals to 2x plus dx. Now we will place or substitute in the question. Question was under root x square plus 1 2x dx, right? So can we write to x square plus 1, we can write under root u, and to for this 2x plus du is du. 2x plus dx equivalent to du. We can keep it like du. Now, simply we will integrate it. Means integration u power half du half plus 1 half plus 1 plus c u power 3 by 2 upon 3 by 2 plus c. Is it clear? We can write down 2 upon 3. In place of now, we will substitute back to u is x square plus 1, 3 by 2 plus c. This will be your answer. I think it's clear and simple also. Let's do some more examples. In one of the questions, if we are integrating 2x plus 3 power 2 dx. Now again, let u equals to 2x plus 3. In that case, if we differentiate du equals to 2 dx, or we can say du by dx. I think there should not be any confusion. If we are differentiating with respect to x, it becomes 2. I think it's clear. We can write it down. Du equals to dx. Sif dx ko is taraf aa gaya hai. No other change. Now, we are substituting in the question. 2x plus 3 will be u square dx. We are integrating it, and in place of dx, can we write du upon 2? Right? So half integration of u square upon du. It will be half u 2 plus 1 upon 3 plus c. Or we can say u upon 3, 6 plus c. I think it's clear. Now we are substituting it back. 2x in place of u, can write x power 3 upon 6 plus c. This is your answer. I think it's clear. Easy? Okay. Now, we are differentiating e power 3x plus 4. In this, again, substitute. If you are going to substitute, let u equals to 3x plus 4. Then, du up with respect to x would be 3. Or we can say du equals to 3 into dx. Right? Or we can say dx equals to du upon 3. One and the same thing. Now we will substitute e power u, and in place of dx, we will write du upon 3. 1 upon 3 e power u plus c, because integration of e power u would be e power u plus c. And I can again substitute it back, e power 3x plus 4 plus c. Or we can simplify e power 3 power x plus 4 upon 3 plus c. This is your answer. I think it's clear. Easy. It's becoming super easy. Now we know 1 upon 5x. Can we substitute u equals to 5x plus 1? In that case, du upon dx would be 5. I can write dx equals to du upon 5. When substituting or in the question, 1 upon u dx. And in place of dx, I have to substitute this. It would be 1 upon u du upon 5. If I will solve it, it would be integration of 1 upon u is 1 upon 5 would be outside, and integration of 1 upon u would be log u plus c. I can write log u 5x plus 1. Again, I am substituting its own value upon 5 plus c. And this will be your answer. I think it's clear. Easy one. Now, 3x plus 4 power 3 dx. Again, u equals to 3x plus 4. Then du upon dx will be 3. Right? I can write u power 3. In place of dx, I can write du upon 3. I will substitute it. 1 upon 3 would be remaining same. U would be power 4 upon 4, means u power 3 means 3 plus 1 upon 4. It would be plus c. I think it's clear. Then the answer would be, I can write u power 4 upon 12 plus c, and I am substituting the value of u would be 3x plus 4 power 4 upon 12 plus c is your answer. I think it's clear. And all the questions of substitution are of the same type. Let's come to the 4x minus 5, 2x square minus 5x plus 6 upon dx. We can make it out if I will write u equals to 2x square minus 5x plus 6. And I will differentiate it with respect to x. It will be 2 to the 4x minus 5 and plus 0, right? I can write du equals to 4x minus 5 dx. I can substitute it. 4x minus 5. Over here, I will write u. And in place of dx, I will write this. In place of x, dx will be du upon 4x minus 5. I can write du upon 4x minus 5. We are cutting it. It would be 1 upon u du. And we know integration of 1 upon u is log u plus c. And I can substitute log in place of u. 2x square minus 5x plus 6 plus c is your answer. I think it's clear. Now let's do some important results. Yes, some important formulas, and we will do the questions based on it. Suppose if integration of fx dx equals to fx plus c, then if this is a condition, then fx of ax plus b and dx would be fx a plus b divided by a. It will be divided by a. Fine. I will do some questions based on it. It's an important result. See, if ax plus b power n, in that case, ax plus b would be the same, and n plus 1, and n plus 1 would definitely come, but at the same time, what is multiplied by x will also be in the denominator. Right? And we will do one question based on it. This is a case. The first thing is I can substitute 5x minus 7 equal to u, and I can solve it. But at the same time, we can do it directly by the formula. We know ax plus b power n dx. It's the same like this. What I can do is I can directly write 5x minus 7 power 3 plus 1 power which is n plus 1. So I will write 3 plus 1 divided by a. A is which is multiplied by 5 is by x is 5. So I will write it 5. N plus 1 is 3 plus 1. Right? I think it's clear. Plus c. It will become 5x minus 7 upon 4. 5 4s are 20 plus c. This is your answer. Directly you can solve these questions. Because in the exam, you have to do the applications of integration. And at the time, if some question comes like that, you don't have to waste your time to substituting and doing it. Because these questions should click directly and you can solve it. Okay? So it's easy one. Now let's do another example. If it is in the denominator, ax plus b. In that case, if something is in the denominator, we know integration of 1 upon x is log x. So something is in the denominator, it means it would be the log of that number plus whatever is multiplied by the x would become in the denominator. Right? That should be the formula and should be clicked. Now let's do one question based on it. 1 upon 1 minus x. When you see this, you feel like, okay, this is 1 minus x, something 1 upon some value that is a integration. It would be something log. So it would be log 1 minus x. But at the same time, whatever is multiplied with x, इसमें x से क्या multiplied है? Minus 1. So whatever is multiplied by x, it would be minus 1. It will come in denominator plus c. See the same formula. So log 1 minus x, and it's your answer, minus log 1 minus x plus c. I think it's clear. Now, do the third important formula. E power ax plus b dx. If something is in power b or power of e, it would be the same. And again, denominator by a. So whatever the coefficient multiplied by x would be in denominator. Right? So let me talk about the next formula. Also the same thing. In this a power lx plus m. Over here, whatever the terms, we will write it in the same way and divided by log a. Because this is a formula you all know about integration. And then whatever is multiplied by x, whatever the coefficient will come in denominator. I think it's clear. We will do the questions based on this 3 and 4. We have done. Okay, 32 question. Okay. Okay, e power 5x dx. E power 5x would be the same and divided by 5 plus c. Whatever is in the power or multiplied by x in the power, that will become in denominator. As I told you in this formula. I think it's clear and simple. Now comes to the next. The 2 power 3 minus x. This is a 2 is a number which is multiplied. We know the formula. We can write 2 power 3 minus x as it is, which is divided by whatever is multiplied by x, which is minus 1. We can see कि हम x के साथ क्या multiply है. हमारे नहीं तो x था ना, ये 1 है. So that is minus 1. And over here, it would be the log of the base 2. I think clear. Answer would be 2 power 3 minus x upon log 2 plus c is your answer. Now, come to the next question of the similar type. But in this, what we will see is we can see x cube and e power x. I think some mistake. Let me correct the question. Is e power x power 4x. Yeah, this is the question. X cube e to the power x4. And now we know if we substitute that u equals to x power 4, it would be du upon dx. It would be 4x cube. Yes? Now, when we substitute in the question x cube e power u dx, we can write du upon 4x cube. That is crossed. The question comes like 1 upon 4 e power u dot du, which says 1 upon u, integration of e power u is e power u plus c. We can substitute again 1 upon 4 e power x power 4 plus c. Or I can write simply e power x power 4 upon 4 plus c. This is your answer. Clear? Now come to the next question. We are doing it for the practice. Just see. You please, all of you, do the questions along with me. Then only you will enjoy. Okay? When we say 1 upon x, we know it's the value of x. We can write u equals to 2 plus log x. We can write du upon dx equals to 1 upon x dx. Right? Now, by substituting, I can write u power 3 upon x. Now, in place of dx, I can write du multiplied by x. We can see it's cut. We get that u cube du, which becomes 3 plus 1 upon 4 plus c. Or we can say u power 4 upon 4 plus c. And again, we will substitute the value of u back to it because this is the answer. But we can't leave the answer in the substitution form. So we will substitute it back. We will write 2 plus log x power 4, which needs to be divided by 4 plus c is your answer. I think it's clear. Come to the next question. 2x plus 1 divided by x square plus 1 dx. Where u equals to x square plus x. Can I write it as du upon dx equals to 2x plus 1? Yes. Or I can say dx equals to du upon 2x plus 1. Now, placing it in place of, I can write 2x plus 1. In place of x square x, I can say right. And in place of dx, I can write du upon 2x plus 1, which says we can cut both of these. Come back to, we will get 1 upon u du, which says it's a log u plus c. Again, we will substitute. Place u as equals to x square plus x plus c, which is your answer. I think it's clear. Let's come. So easy. See, integration is very easy. It's only the matter of practice. And in your BCom honors, you don't have the typical trigonometric or inverse of it. So it's easy. Now come to the next question, which talks about x square, which is cube root of 2x cube plus 9. I can say u equals to 2x cube plus 9. I think it's clear to all. Du upon dx, it would be 6x square. I think it's clear when we are differentiating it. I can write x square and I can write u power 1 upon 3 du upon, because in place of dx, I will write du upon 6x square. I can see x square is cut with the x square. I left with 1 upon, or better to say u power minus 1 by 3 upon 6 into du. Your 1 upon 6 will while integrating, we can bring it out and you will get it. 1 upon 6 u power half 1 by 3 plus 1, which is divided by, it will be 2 by 3. Or I can say it would be something like 2 by 3, right? Plus c. And at the time of solving it further, I will write 1 upon 6, 3 upon 2, u power 2 upon 3 plus c. I can write 4 u power 2 by 3 plus c, or we can say in place of u, I can replace it back. X cube plus 9, 2 by 3 upon 4 plus c, which is your answer. This is your answer, I think is clear. Easy one. Now, another some important formulas we will talk. Suppose in the formula, if function and the differentiation of it, they both are multiplied. In that case, you will simply integrate it. Fx, whatever the function is, you in the power n plus 1 n divided by n plus 1. But if in the case it's is in the denominator function and the derivative of it is in the numerator, in that case we will make it log of the function. Let's see. It's a direct questions. Let's do something like 38, which is log x5. We know it's just equivalent to this type. First thing, we can solve it by the substitution also. If nothing comes up, simply substitute. Let log x. Then I will tell you directly from the formula also. But from the substitution, u equals to log x. You can say du upon dx. And none of the question is wrong. None of the answer is wrong. Du upon is 1 upon x. I can write log x. Can I write power 5 upon x? And for the dx, I can write x into du. It can be cut. If the things comes up like u power 5 du, which means u power 6 upon 6 plus 6. In place of u, you can write log x power 6 upon 6 plus c is your answer. Or even directly by the formula, I don't have to solve it, substitute it directly, as we know, if we differentiate, it would be 1 upon x. Means it's in the multiplication. I can say so. Integration log x power 5, which is in the power 5. n हमारा 5 है. Then we are multiplying by इसका integration differentiation क्या है? 1 upon x is dx. This is the same formula. I can solve it directly. I can put function means log x, whatever the function n is 5 plus 1 upon 5 plus 1 plus c. I can say log x is power 6 divided by 6 plus c. And you can see directly same answer. Whether you solve it by the substitution or whether you go by directly by the formula. It's one and the same thing. The another one, again, the same question. Again, this is in the form of this formula. If I differentiate it, it would be the one in the numerator. So directly I can solve it. It would be, answer would be log e power x minus e power minus x plus c would be your answer directly. You don't have to put much energy or efforts. नहीं तो you have to differentiate करो. You first इसको substitute करो. इसको आप u कर लो. And then whatever you will get it, you will get this and multiply the same substitution method which we have done previously. You can try it by the substitution also. But directly we can solve it by the formula log. This would be your answer. Is it clear? No. Another question, simple again, substitution questions, only for the practice we are doing it. I'm doing it fast, you also do it. So that you will be confident before going for the application of integration. It is du upon dx. It will be 4x. I can write dx equals to du upon 4x. Right? Now by substituting x upon, in place of 2x square plus 1, I will write u. And in place of dx, I will write du upon 4x, this thing. And I can see x can be cut by x. We can write 1 upon u. 1 upon 4 is outside, upon u du. It will become log u upon 4 plus c. Again, I will substitute back. Value of u is 2x square plus 1 upon 4 plus c is your final answer. I think it's clear by substitution. Now, another simple question, solve dy upon dx equals to x multiplied by under root of x square plus 1. Given that y equals to 6 at x equals to 0. It is given, it means if something like this is given, it means they want me to calculate the value of c, right? So, right. Dy by dx equals to x root x square plus 1. I can say u equals to x square plus 1. Right? So can I say du upon dx is equals to 2x? If it is like that, can I write y equals to integration of x square plus 1 dx? Integrating both sides, and it would be, in place of x, I can write u x square u. In place of dx, I can write du upon 2x. We can see. Now we get it easy one, power 1 by 2 du. You can solve it. One upon 2, this value. 1 upon 2, it would be u 3 by 2 upon 3 by 2 plus c. I can say u power 3 by 2, and 2 would be, again it will be, when I will reciprocating it, it would be 3 multiplied by 2, and over here 2. I can say the both have been cut, plus c. It would be u 3 by 2 upon 3 plus c. We know this value, and at the same time, can I keep the value of the, now I'm substituting it back, u will be x square plus 1 upon 3 plus c. I think it's clear. हमने substitute back कर दिया, तो हमें, now we have the y equals to 6 when x equals to 0. They are saying so. ये मेरे को y की value मिल चुकी है, when I say 6, अगर y is 6, at the time x is 0, means I am placing the value of x 3 by 2. Okay, I would say 3 by 2 upon 3 plus c. I think it's clear. It would be 6 equals to, it will be 1 upon 3 plus c. I can say c is equals to 6 minus 1 upon 3, which is 17 upon 3. So I can say my final y equals to, because in the question solving for y given that, okay, y is x square plus 1 upon 3 by 2 upon 3 plus, in place of c, I will write 17 upon 3. I think it's clear and easy also. Okay, let's take a break for the 2 minutes, and then we will come back for the integration by parts.